Today I'll be discussing how rhodopsin is formed, with emphasis on the tetrahedral intermediate leading to imine formation. Beta-carotene is cleaved by beta-carotene 15,15' monooxygenase to form an epoxide intermediate. This epoxide is then attacked by water. Two alcohol groups are formed, which are ultimately resolved in two new molecules of all-trans retinal. The aldehyde is then converted into an alcohol enzymatically. NADH is converted to NAD positive in this process. We now have all-trans retinol. Our new molecule of all-trans retinol is converted to 11-cis retinol via an all-trans retinyl ester intermediate. Our molecule is now in cis configuration. This is important because our rhodopsin molecule must be cis in order for our vision to function properly. Next, our 11-cis retinol is converted to 11-cis retinal. This mechanism requires the NAD plus from earlier to take the hydrogen and its electrons in order to convert back to NADH. This forms a carbonyl, which is our aldehyde. Now that our aldehyde is in the 11-cis configuration, we are ready to add opsin. I'm going to abbreviate it like this and show only the business end of this molecule, which is this amine group. Because this nitrogen has a lone pair, it can attack the carbonyl in a concerted reaction that will form a tetrahedral intermediate. A tetrahedral intermediate is an sp3 hybridized carbon that has at least two molecules that can act as leaving groups. Tetrahedral intermediates are central to organic chemistry and play important roles in many reactions, including glycolysis and the citric acid cycle, fatty acid metabolism, and others. Predicting carbonyl chemistry requires the following knowledge. How strong is the nucleophile? Will a leaving group be formed? How many and how good is that leaving group? And what are the conditions and what molecule is most stable in these conditions as a product? Once you have a tetrahedral intermediate, the most important question to always ask yourself is there a leaving group? In many cases, such as this one, you might have two leaving groups, which actually allows the reaction to reverse itself. This is completely possible, and it does happen, perhaps many times before the nitrogen finally kicks out the oxygen. But eventually, we will end up with a tetrahedral intermediate in which this nitrogen will kick out the oxygen, and we will form an imine group. This amine is now the connecting group between the original molecule and opsin, and we now have rhodopsin. Once rhodopsin is present in the eye, the 11-cis configuration will photoisomerize to all-trans in the original carbon chain in the presence of light. This configurational change is what stimulates the nervous impulse, which is interpreted by our brains as vision. This is a reversible reaction. That opsin with the amine group will come off and be replaced by an aldehyde group, which will then be converted back to an alcohol group. The whole thing will be changed back to cis. We'll add the opsin again, and we'll be ready to start over.